today we are going to start the work for energy. That is the new topic. Okay. So far we have discussed about the forces. Okay. So under the starting from the Newton's law, we discussed about the tension, we discussed about the spring force. Okay. And in the dynamic, in the circular motion, we discussed about the centripetal force and centrifugal force. So different various forces we are introduced. And now we are going to calculate the work by all those forces. Okay. So in a particular body, so there may be different types of forces may act. Now our intention is to calculate the work due to that particular force which is acting on that. Okay. So in this topic, there are three subtopics are there. First we discuss about the work, then energy, and then lastly power. Okay. So these are the three topics that are mainly covered under this particular chapter. The similarity between these three parameters are basically all these are scalar quantities. Okay, all these are scalar quantities. So you don't have to bother about the direction of all those quantities. So they can be added or subtracted by simple addition and subtraction. Okay, scalar rule. So starting with, we are discussing the work. So let us say I am starting with a problem. Let us say there is a man who is trying to move down an inclined plane whose angle of inclination is given as theta. Okay. So the height of the man where it is located initially is, let us say, h, and he is coming down, and assuming that there is no friction. You assume that there is no friction in this particular surface. So mu is equals to 0. So now when the person coming down, so what is the velocity with which it will come down? Okay, that is the question you are asking. So now this is a simple type of problem, and that can be solved using the knowledge of Newton's law also. Okay. Why? Because whenever the person is coming, let us say the person is at any position where the acceleration will be due to only the weight of the body. Okay. So in this direction, the force acting on this body is mg sine theta. Sine theta. Corresponding to that acceleration of the particle or the body is nothing but g sine theta. So that means acceleration is always constant. Okay. Now, if the acceleration is constant, now I can calculate what is the velocity with which it will come down. Let us say if the particle covers the distance a to b, and that distance is how much? Let us say this is x. Okay. So let us say I am saying AB length is x. So can I say that x sine theta equals to our h component? No, x sine theta. Yes. Okay. So what is x? X is equals to h by sine theta. So this is the displacement of the object. And the displacement takes place with the constant acceleration. So now we can use the formula that v square equals to u square plus 2as. Okay, to calculate the velocity once it reaches it. So let us say the particle starts with 0 velocity. So initially u equals to 0. So ultimately we are left with 2 times a means d sine theta into s. S means h by sine theta. So ultimately what we are getting, that is 2 times g into h. V square equals to, or what we can say, v equals to under root g. Okay. So this is the velocity with which the particle or the man comes once he reaches the bottommost position of the inclined plane. Assuming that there is no friction and also that the slope is constant. So for that situation we apply the Newton's law of motion, and then we apply the basic kinematics formula to get the result. So there is no need for any other method. But if I do the same problem by saying that now the man is coming down with a slopey land, but the slope is gradually changing. Let us say initially once he started, this is the slope number. Let us say this is a theta 1 number. At any intermediate position, number is theta 2. At another intermediate position, let us say number is theta 3. So gradually the slope is decreasing. So hence the slope is decreasing. That means what we can consider that at any instant, if I say a theta 1 position, the acceleration of this object is g sine theta 1. Okay. Similarly, here it will be g sine theta 2. So that means what you can conclude that the acceleration is now varying. Okay. Now, if acceleration is varying, that means now the problem is more difficult. Okay. So it becomes comparatively difficult to solve this type of problem. Again, the question is same. Once the person reaches the ground, what is the velocity? I want to calculate it. Okay. But with the knowledge of Newton's law, as well as the kinematics equations, I cannot calculate this. Okay. So for this type of problem where we are finding difficulty to calculate the velocity or any other parameter, so we have to think about some other methods. Okay. So here the slope is continuously changing. Gradually the slope is changing. Because of that, the acceleration is also changing. Okay. So since the acceleration is changing, that means now if I want to calculate the velocity with which the person comes down, is quite difficult to calculate because with the knowledge of simple Newton's law or the kinematics equation, you cannot calculate. Okay. So this is the basic requirement. So for that, you should go for this segment of chapter where you understand what is. So whenever I write the work, so work cannot be done without a force. Okay. So in order to calculate the work, there must be a one type of force. So that's why the name is work done by a force. By a force. Now regarding the force, we have the concept that there may be different types of forces. So there may be one force is the normal force. There may be another force tension force. There may be another force spring force. There may be another centrifugal force in this curve by R force. Okay. There may be friction force. So a lot of force we have already studied. Okay. So depending on the which type of force is acting on that particular object, so there may be a combination of more than one force, two force, three forces may be there. So for each and every force, I have to calculate the work. So that's why the name is work done by A. So let us say I have applied a force of A and the particle is displaced from point A to point B and S is the displacement vector and 8 is the force vector. So work done by this force, work done is written by dot product of force vector and displacement. This is the expression for the work. Okay. So whenever you do the dot product of the force and the displacement vector, that means I am going to get the Fs cos theta number. Okay, Fs cos theta. So that will give the value of work, provided we can apply this concept whenever we are saying this work is being done by a force and that particular force is a constant. Okay. If this force is constant, it is not varying. Force is constant. Let us say I am applying a 10 Newton force on a particular body. So that 10 Newton number is constant. It is not changing. So then only I can apply this formula to calculate the work done by this particular force. What is that? That is that you have to find out what is the direction in which the force is being applied and displacement of the particle is to be known that it is displaced from point A to point B. So S is this direction, this is the direction of S vector. Okay, force is given. So direction of the force vector and the displacement vector making an angle theta. You have to take into that into consideration and depending on that you have to calculate the what is the work done by whom, by this force. Okay. So if there are several forces are acting on this particular body, so for all the forces you have to apply the same force. Provided the forces are constant in that. Okay. So this is the final expression. So work done by a constant force. So we are discussing the first topic of this lecture is that work done by a constant force. So whenever I am going to calculate the work done by a constant force, I have to identify what is the nature of this particular force. First of all, you have to identify that whether it is external force or normal force or any other force is acting on that particular body or not. And depending on that, you have to identify what is the direction of displacement. Once you identify these two components, then you take the angle between this. Depending on the angle value, the work done can be written as F dot A, or I can write simply F S dot. Since I am doing the dot product, so it is a scalar quantity because dot product always gives the scalar results. So work is also a scalar quantity. Okay. So this final expression is F dot S, or in the different way, I can write it in two different manner also. Either I can write that is equals to Fs cos theta. Simply write Fs cos theta. Or can I write F cos theta into S? F cos theta into S. Or S cos theta into F. Yes. Both are acceptable. Okay. So what is F cos theta meaning? F cos theta means the component of force vector along the displacement. Yeah. So this is nothing but the F cos theta now. What is that F cos theta? That F cos theta is nothing but the component of force along the displacement. Okay. So either I can define the work as dot product of force vector and displacement vector, or you take the multiplication or the product of component of force along the displacement with F cos theta multiplied by the displacement. Or in other words, let us say the force acting in this direction is let us say A. Okay. And this is the displacement direction A is vector. So this angle is theta. Now you can take the component of S vector also. So if I say component of S vector, so it should be S cos theta. Okay. So can I say the work done is nothing but the product of force and the component of displacement along the force? Okay. So once I resolve the force into two components, one component should always be along the displacement. You have to take that component. That component is cos theta component. So that component is nothing but the component of force along displacement, or in the other way, I can also take the component of displacement along the force. Okay. So these are the three different ways to define the work. So first is simply write F dot S. Okay. Second way is write F cos theta into S. Or the third possibility is the S cos theta into F. Okay. So definition will change. Either I can take the component of force along displacement, or you can take the component of displacement along force, or simply take the dot product of A. Okay. So whenever I am willing to apply this formula, that is F dot S, you have to clearly understand what is the direction of the force vector and direction displacement vector. If you take the different direction, then the answer will be wrong. Okay. So here the direction of force and displacement is important. Why? Because that direction is the value of theta. Okay. Now regarding the basics of work, so what we can conclude. So regarding the unit of work is a scalar quantity. Why? Because it is dot product. And unit is Newton into meter, or I can say simply this I in CGS I can use 9 centimeter or R. Conversion then R is 1 because 10 to the power 7 R is 1 because 1 meter 1 meter equals to 10 to the power 5 9. Yes. And 1 meter equals to 10 to the power 2 centimeter. That is 10 to the power 7 9 centimeter, and 9 centimeter is nothing but R. Okay. So that is the conversion between the Joule and R. Now there is another separate unit to measure the energy, that is called the electron volt. Okay. So it is very small unit. 1 electron volt equals to 1.6 in 10 to the minus 19 times Joule. So that number is basically the charge of electron. Okay. So 1 electron volt equals to 1.6 in 10 to the minus 19 Joule. Now electron volt is a separate kind of unit. What is that unit? I will explain it. Let us say there is an electron. So electron is negatively charged. Nah? Electron is negatively charged. Now we put this electron in a container. Okay. And you apply a electric field by connecting battery. Okay. So you connect the battery like this way. So this becomes the positive terminal, this becomes the negative terminal. Now between the because of the battery provided over there, so there is an electric field from the positive terminal to the negative terminal. So this is the direction of electric field that has been created due to, let us say, V volt battery. Okay. I apply a V volt battery system, and once I switch on the circuit, there is an electric field created. And because of this electric field, now the electron will be accelerated in this direction. Okay. Why? Electron will always move opposite to the electric. Now ultimately it will reach the next position here. Once it will reach over here, initially electron has zero energy. Why? Because the kinetic energy is zero. Because the electron is zero. Now once it reaches over there, the kinetic energy is equals to becomes E times capital E. What is E? E is the electronic charge. E is the applied potential or the battery voltage that we have applied over there. So that is the kinetic energy of the electron. Now if I apply 1 volt battery, then what is the energy? Can I say E joule? No. So this number is basically our electron. Okay. So when an electron is accelerated into 1 volt battery, then the energy possessed by that electron is known as 1 electron. Okay. If I use 10, let us say I am using 10 volt battery. So what is the energy of that person electron? It should be 10 electron volt. Okay. So kinetic energy of the electron can be given as 10 electron volt. Like this one. If I apply 1 volt, then the energy is 1 electron volt. If I apply 10 volt, then the electron energy will be 10 electron volt. So this electron volt is a very small unit. And mostly it is used in the nuclear physics part. Whenever we deal with the nuclear physics part, then we have to go for very smaller unit. And in that situation only, I should go for the electron volt unit. But right now, we should go for only Joule or Arc system. Okay. Now, so we are discussing about the work done by a constant force, and one of the important property of this work is that it is path independent. Okay. That means if I want to move a particle from point A to B, let us initially the particle point A, and I want to move from point B to point B. So for that I apply, so that force is creating a displacement and the particle is moving from point A. Now the movement of point A to B can be occurred by different path. Let us say I am taking the particle from A to B by following this path. Okay. I can also move through this path also. Okay. I can also move through that path also. So there will be infinite number of paths which is connecting the point A and B. Can I say? So this may be the path number 1, this may be the path number 2, this may be path number 3. Like this way, I can join infinite number of paths connecting the two dots A and B. And I can say that the particle is displaced with the application of force and by following the path number 1 or by following 2 or by 3. Okay, like this way. So whenever I am displacing the particle by any of the path, the work done is path independent. That means work done involved in path number 1 is equals to work done in path number 2 equals to work done in path number 3 like this. Okay, that means it does not depend on the path. Why? Because in the definition of the work, what I am saying that the product of force and displacement. Nah. So displacement is what? Displacement is delta R. So it is nothing but the position of point A, that is R1 vector, and position of point B, R2 vector. If I follow the triangle rule, so I can write R1 vector plus delta R vector, that should be equals to R2 vector. That means delta R vector should be equals to R2 minus R. Okay. That means this is the displacement vector that we are looking for. S vector. Okay. So product of A, so work done should be how much? Product of A dot S. That means what you can write? AF into delta R into cos of theta. What cos theta? Because that theta angle is given. Okay. So that means delta R is dependent on what? Delta number depends on the position A and B. Okay. Delta depends on the R1 and R2. So that is the position vector. If I choose another path, let us say I am following this path number 2. So for path number 2 also the position of A and B is fixed. Okay. So for path number 2, delta R vector is also R2 vector minus R1. So delta R vector is not going to be changed. Why? Because I am not changing the position A and B. So that's why I can say that whenever we apply a constant force, work done by a constant force has to be constant. Then only it is independent of that. Okay. If I apply, let us say 10 Newton force on a particle, and for that 10 Newton force, the particle is displaced from point A to point B, and I don't have to bother on which path it follows this. Okay. It may follow path number 2, it may follow any other path like this, path number 3. Okay. So it may go through any path, but once I reach from point A to point B, the work done by this constant force is always going to be constant. Okay. So that is the important conclusion regarding the work done by a constant force. So now, once I am saying work done is equals to Fs cos theta, work is equals to Fs cos theta. Now this cos theta number is going to be important. Okay. So you know that whenever the angle is acute, let us say I am applying a force on this particle, and for that the displacement occur in the right hand direction, so that you can say this theta angle is acute angle. Now if the angle theta is acute, then what you can conclude that work done by the force is always positive. Okay. Work done is positive. Why? Cos of theta becomes positive. Now whenever I am doing a positive work, then the speed of the body should increase. Okay. So whenever we go for a work calculation, and if I got the number of the magnitude of the work to be positive one, that means I can conclude that due to this work, the velocity of the body is going to increase. Let us say this boy is pushing this car. So he is applying a force in this direction. Yes. So the direction of displacement is same direction. So what is the angle theta? Theta is 0 degree. Yeah. Okay. So for this situation, gradually, if you say the car is starting from base, so after some point of time, the car will acquire some kind of velocity. Velocity will increase. Why? Because it will speed up. Why? Because work done by this force is because how much? F into AC. Because cos theta becomes 1. So that number is positive. So since the work done is positive, I conclude that the speed of the body will increase. So this is the positive one. Similarly, what can be negative? When the angle, this theta angle is greater than 90. So when theta is greater than 90 degree, that is the obtuse angle. For this situation, the cos of theta becomes negative. That is the work done becomes negative. And if the work done is negative, that means the body will slow down. So when the work is positive, the body will increase its speed. When the work is negative, then the body will slow down. So in this situation, the boy is pushing the car in this direction, but Force is not sufficient to hold the car, so car is slipping down. Okay. So car is slipping down, means now the theta angle is 180 degree. For this situation, work done is how much? Work done should be minus 18. Right? Cos of 180 is minus 1. So work done become negative, so velocity of the body is going to reduce, or the speed of the body is going to reduce. Okay. So either work may be positive or work may be negative, and as well as work may be zero also. So zero becomes when the theta angle is 90. Okay. Let us say I am pushing this book with the force A. Okay, with the force A. Because of that, the book has been displaced by a S displacement. Now, if I consider the weight of the body, so corresponding to this force mg, the displacement is making a 90 degree. Similarly, corresponding to the normal force, the displacement also 90 degree. Okay, so can I say work done by the normal force is equal to 0? Work done by the weight, gravity, that is also 0. But work done by the external force, A, is equals to how much? F into S. That is a positive. Okay. So in this particular situation, there are three different forces that is acting on the body. So one is the external force. I am applying this force. The boot has some kind of weight, so weight is acting downward, and the floor is offering some kind of load. So for three different forces, so what have some other different values? Okay. So one work is positive, one other work is negative zero, another work is also zero. Why? Because zero? Because in this situation, the theta becomes 90. So whenever the theta becomes 90 degree, so work done by these forces. So there is no work because cos 90 becomes zero. Okay. So at every point, whenever the particle performing circular motion, you know that whenever the particle circular motion, centripetal force is acting towards the center, FC, and centrifugal force, the mv square by r force is acting away from the center. Now for both of these two forces, the displacement is making an angle 90. Can I say that? So
Yes.
both of these two forces, displacement is making an angle 90 degree. So work done by the centripetal force. In this situation, centripetal force is let us say tension in the string. So work done by the tension, work done by the tension, or work done by the centrifugal force, both are going to be zero. Okay, because theta is 90 degree. So whenever the situation comes that you have to identify which one is positive work, which one is negative work, and which one is zero work, you have to be very cautious regarding the direction. You have to identify the theta angle properly so that you can see which forces are getting the zero. Okay. In circular motion, every time the centripetal force and the centrifugal force are not giving any kind of. Okay. So since these two forces are not giving any kind of work, so these forces are known as the no work. No work. So force is there, but still they are not able to produce any kind of. Why? Because the angle become 90 degree. They are giving displacement. Displacement is there. Force is there. Both are non-zero number, but still work becomes zero. Why? Because the angle becomes 90 degree. Okay. So whenever this type of force comes into the picture, that means these forces are called the no work. Okay. Let us do one problem. Let us say there is a force acting on the particle 2i plus 3j plus 4k. And because of this force, the particle displaced from point A to point B. So for point A to point B displacement, I can calculate the displacement vector as position vector of B minus position vector of A. Okay. So displacement is from A to B. So particle moving from point A to B. So S should be equal to RB minus RA. Now what is RB? RB is 3i plus 4j plus 3k minus I plus 2j plus k. Okay. So that means 2i plus 2j plus 2k. Okay. So this is the displacement vector. Now force vector is given. So simply work done should be equals to force dot a vector dot s vector. So that means 2i plus 3j plus 4k dot 2i plus 2j plus 2k. Ultimately 4 plus 6 plus 8, 18. The 18 joule is the work done. And since we got this number to be positive one, so directly I can conclude that because of this force, the speed of the body will increase. So velocity of the body will increase. Why? Because what that we are getting is positive number. Okay. Now, let us say another situation is there. You are applying a force of 10 Newton on a particle which is making an angle 37 degree. So for this situation, what is to calculate the work done by this force after 2 seconds. After 2 seconds. So if I resolve the force in two components, can I say this is the F cos 37 number? Yes. So that means it is 8 Newton. Okay. And the vertical force is how much? F sin 37. That is 6 Newton. Okay. 6 Newton. So corresponding to 8 Newton, the particle has got some kind of acceleration. So what is the acceleration? Acceleration equals 8 by 2. That is 4 meter per second square. Okay. Because of this acceleration, the particle has been displaced. Now what is the displacement? S can be equals to ut plus half at square. Now if I say initially the particle is at rest, so that means it is simply equals to half into at square. Now A is 4 and T is you are waiting for the 2 seconds. So 4, that means 8 meter. So because of this force, the particle is displaced by 8 meter. So correspondingly, what is the work done? So work done, I can say that 10 Newton force is there, which is producing displacement of 8 meter, and the angle between them is cos 37. Okay, this can be written. So that is how much? There is 6 into, 8 into 8. 8 into 8, that is 64 joule. Okay, that will be your answer. So work done by this force is 64 joule. What force? 10 Newton. So for 10 Newton, there are two components. 10 Newton, there are two components. If I calculate the work done by the 8 Newton, what is the answer? Work done by 8 Newton should be equals to 8 into 8. That is 64. That means this is the answer. Okay. But work done by 6 Newton is 0. Why? Work done 6 Newton is acting vertically upward. And for this displacement is at an angle 8 meter. So work done by 6 Newton is 0. Individually, I can also calculate the work done by the component. Okay. So 10 Newton has two components. One is 8 and another is 6. 8 is doing your work answer, but 6 is not doing any kind of work because 6 is perpendicular to the body. Displacement. Okay. So this is how you have to manage. This is how you have to calculate the questions. Okay. So these are the some problem. Let us say this is the problem. What is subjected to a constant force given by this number? What is the work done by this force in moving the body to a distance of 4 meter along z axis and 3 meter along y axis? Initially, the particle is at origin. After that, so it is a point. After that, it goes to point B, where the z coordinate is 4, y coordinate is 3, and x coordinate is 0. So 0, 3, 4. This is the B point. So this is the S vector. So what is S vector? S vector is RB minus RA. Now what is RA? RA is 0, I 0, J. RA is the origin. So only we are left with PJ plus 4K. So that is our S vector. So force is given. So work done should be how much? Work done should be equal to minus I plus 2J plus 3K dot 3J plus 4K. Okay. So 3 into 2 means 6 and 4 into 3 means 12. Okay. So that means 18 joule. 18 joule work is being done on that particle to displace the body from point A to point B and whose coordinates are given. So this is how you have to solve it vector. Okay. So whenever the informations are given in the vector format, so you have to use the dot product tool to calculate the work done. So for that you have to calculate the displacement. So for calculation of the displacement, the hints has to be given. So it has been given that the particle is displaced from this point to that. You have to identify what is the final position. And once you identify the final position, now we can draw the displacement vector. Accordingly, you can solve it. Okay. So let us say there is a friction. Let us say there is a friction. So I am applying there is a 6 kg block and it is displaced by 12 meter along a horizontal surface at a constant speed. Now what is the meaning of constant speed? That means you are applying a force in such a way so that there is no acceleration. Acceleration is 0. Constant speed means acceleration is 0. Now you are applying a force and because of that the particle is displaced, but it is displacing at a constant speed. If the coefficient of kinetic friction is 0.2, Because the particle is moving, that means this number is mu k. It is not mu s. Mu k is 0.2. And the cord pulling the block is at an angle 40. You are applying a force at an angle 45 degrees so that the block will move. Then calculate the work done by this person. Okay. So displacement number is given. So only thing you have to calculate the S number. Okay. So corresponding to this 8 value, let us say 8 number is there. So can I say this is 8 by root 2 component, 8 cos 45. And this 8 by root 2 another component is there. Okay. Now, since the block is moving towards right, so friction will come in this direction. The friction value should be Fk. Now, what is Fk? Fk should be equal to mu k into n. Now, for the 66 kg block, 60 Newton force is acting downward. Now, 60 Newton is acting downward and upward normal. So now I can use this equation to calculate the n and Fk. Now, there is no acceleration. So, since there is no acceleration, net horizontal force should be balanced. So, I write F by root 2 should be equals to F. Okay. So, F by root 2 is rightward, F is leftward. So, F by root 2 should be equals to F. Now, what is F? F equals to mu times n. So, 0.2 into n. Yeah. What is n? N plus F by root 2. That number is equals to 60. What is n? N equals to 60 minus F by that number. Okay. Now I can put that number. So capital A by root 2, that should be equal to 2 by 10 into n. N means 60 minus F by root 2. Okay. So take this F by root on the other side. So it should be 1.2. 0.2 plus 1 means 1.2 F by root 2 should be equal to 60 into 0.2. 60 into 0.2, that means 12. Okay. So correspondingly, F should be how much? 12 divided by 1.2 into root 2 is the number. 12 by 1.2 is 10, so it is 10 root 2. So 10 root 2 is the force. Got it? 10 root 2 is the force. So 10 root 2 force is acting on that particular body. Corresponding to that, what is the displacement? The displacement is given as 12 meter. Okay. Displacement is given as 12 meter. So 12 meter displacement. So work done should be equal to how much? F into cos theta. The F is how much? We got it as 10 root 2. S is how much? S is 12 meter. And theta is 45 degree. Cos of 45 means 1 by root 2. So ultimately what is got? 120. Okay. So that is the answer. So in this situation, the particle is moving with a constant speed. That means you should not apply any kind of acceleration on this. Okay. So that means this F by root 2 component is balancing this kinetic friction. And kinetic friction is what? That is mu k times n. Now in order to calculate the n, you should equate the vertical component. So once I equate the vertical component and horizontal component, so I calculate the F. Once I calculate the F force acting on the particle, now you can calculate the work done. Okay. So like this way, so let us say this problem. Now, there is a small block of mass m kept on a rough inclined surface. So here the surface is rough. Friction is there of inclination theta in an elevator. The elevator goes down with a uniform velocity v. Elevator is moving downward with an uniform velocity v, and the block does not slide on the edge. Block is not sliding along the edge. That means it is not moving. The work done by the force of friction on the block in time t. Okay. So why the block is not moving? Because friction is supporting. So if let us forget about the lift part. So downward component of force, that is the mg sin theta is there. So this force is trying to pull the block downward, but block is not moving. That means here the friction acting is F. So what is the value of F? F number should be equal to mg sin theta. Because of that friction force only, the particle is at rest. Okay. Now the friction is over there, and after time t, this point of application of the friction force will come down. By how much? By distance of half. So v is constant, na? So this distance is basically, let us say initially the block is at point A. After some point of time t time, the block will come to point B. Got it? So this is the new position of the block. So what is the distance AB? Can I say AB length is equal to Vt? Can I say AB length is equal to Vt? Distance. Yes, speed into time. Because the particle elevator is moving downward with a constant speed. Now identify the friction. Let us say this is the point A where the friction is acting. So this is the direction of friction. Now displacement in this direction. And displacement is vertical downward direction. Now this angle is theta. This angle is theta. Then this angle is 90 minus theta. So this angle should be 90 plus theta. Understood? Okay. So work done by friction. You are asked to calculate the work done by friction. So work done by friction should be how much? Work done by friction should be equals to F dot S into cos. F is what? Friction. Displacement is how much? Vt into cos of 90 plus theta. Understood? Cos of 90 plus theta. So now put the value. F equals to mg sin theta. Mg sin theta. And displacement is Vt. And cos of 90 plus theta is how much? Minus sin. Here we should write minus sin theta. So ultimately what we got? Minus mg Vt into sin square. That will be your answer. Minus mg Vt sin square theta means option C. And not the option B. Why? Because answer is negative. So here the work done by the friction becomes negative. Why? Because it is clearly observed that the angle between the friction force and the displacement is 90 plus theta, which is obtuse angle. Okay. So this angle is obtuse. So since this becomes obtuse angle, so answer for the friction should be negative. Negative has to be there. That's why the negative number is coming. So every time in order to calculate the work, what you have to consider that what is the force that is applied, for which force you are willing to calculate the work done first of all, and then calculate the displacement. What is the displacement of that particular point? Okay. So point A is the point where the friction is being applied. Now we want to calculate what is the displacement of the point A. So the point A is displaced vertically by a distance of Vt. So for that reason, I calculate this displacement Vt. Okay. So that's why we got the. Understood? Okay. Now we move on to. So far what we calculate? So far we calculate the basic definition of basic definition of work. Now we are going to the next topic, that the work done by the various forces. Okay. So whatever the forces that we have learned so far, we want to calculate the work done by these various forces. So basic formula for the work done remains same. Only thing is that now I am applying different types of force on the structure system, and I want to check what is the answer or what is the output of that. So what are the different forces that are going to focus? So first one is the gravity force, that is the body force. Then the normal reaction, tension, these are the situations. Okay. So there may be situation with pulley block system or simple block system. Whenever I am pulling this block and pushing this block, there is a normal interaction force between these two surfaces. Here the normal will come. Now, so what is the reaction force that comes in the picture, and what is the displacement of the particular point? Depending on that, I can calculate the work done by the normal. Similarly, whenever the strings are there, so I can calculate the work done by the tension. So these forces are to be identified, and accordingly, I have to calculate the work done involved in these forces. Okay. So let us say first we want to calculate the work done by gravity. Let us say there is a block of mass A. So weight of the body is acting downward. Now, if this block is moved downward by a distance of S, so can I say that theta angle is 0 degree over here? Because force and displacement are in the same direction. So once the force and displacement are in the same direction, so theta becomes 0 degree. So for this situation, F should be how much? F should be equal to simply mg into S into cos of 0 means 1. So that is work is positive. Okay. So when the object moves vertically downward, then the work done by gravity is positive. Why work done by gravity? Because this force that we are talking about is the gravitational force. So for this force, the work done becomes positive. Okay. Similar way, if the object is now moving upward, gravity is not changing its direction. So gravity is always vertically downward acting. Okay. Now I am moving the body in the upward direction. So for this situation, theta becomes 180 degree. Theta becomes 180. So once theta becomes 180 degree, so work done should be how much? Mg into A into cos of 180. And cos of 180 is minus 1. Ultimately, I am getting minus mgs. Okay. So work done becomes negative. Whenever the particle is moving upward, then the work done is negative. If the particle is moving downward, then work done is positive. By whom? By work done by gravity. Okay. by Ward by gravity. So clearly it is understandable from this two exercise is that, are you there?
Yes, sir. Yes, sir.
Yes. So here in the earlier situation, the block is moving in the downward direction, so that means work done by the gravity is positive. In the next situation, the block is moving upward, so work done by the gravity is negative. Okay, that means it may be answer may be positive, it may be negative, it may be zero also. It may be zero also. In this situation, it becomes zero. So weight is acting downward, and you are moving the block towards the right or left. So now this theta becomes theta becomes 90 degree. Huh. And for this situation, work is becoming zero. Now here the situation is that work is zero. So for these three different situations, what you understand that work done by the gravity may be either positive, maybe either negative, or maybe zero. So it depends on the situation. It depends on the situation. So ultimately, what you can conclude that work done by gravity is a constant. Gravity is a constant. Why? Because mg force. Once I select a particular value of mass, so for this mass, the mg is acting downward, and this number is constant. No, it is not going to be changed. So I want to calculate the work done by the constant. And you know that work done by a constant force is independent of path. Okay, that means work done by gravity is also equal, right? Because if I move the block from point A to point B, following let us say three different paths. So I move the block A to B by following the path number 1 or path number 2 or path number 3. But answer remains same. Why? Because whenever I am displacing the block, I have to calculate the displacement. And displacement depends on the initial and final position. Okay. Displacement depends upon the initial and final position. So initial and final position are fixed. So what is the displacement? Displacement is, let's say, this is the vertical displacement is S. Okay. S number is fixed. So since S number is fixed, that means what we can conclude that the work done in all the situations remains same. It depends on the initial and final vertical coordinate of the object. If the vertical coordinates remain same, what we can conclude that the work done for this particular body under the gravity is always constant. Okay. Now come to the normal force. So whenever the block is resting on a floor, so normal is there. So here I can say this is the direction of normal. Okay. In this situation, this is the direction of the normal. In this situation, this is the direction of the normal. In the first case, the displacement is along v direction. This is the displacement vector. The second case, this is the displacement vector. Third case, displacement vector this direction. Okay. In the first case, theta is 90 degree. Can I say that? Here theta becomes 150 degree. Here theta becomes 0 degree. Okay. So here work done by normal is positive. Here work done by normal is negative. Here work done by normal is zero. Again, there are three possibilities. Okay, again there are three possibilities that work done by the normal may be positive, may be negative, may be. Because you have to identify the direction of the normal force. And apart from that, you should also identify the direction in which the normal force is displaced. Okay, what is the direction displaced? Since the lift is moving downward, I am saying the displacement is also down. In this situation, lift is moving downward, so displacement is downward. Here the lift is moving upward, so displacement is upward. And in this situation, block is sliding downward, that means displacement is downward. Okay. So you have to identify in which direction the displacement takes place, and accordingly you have to calculate the work. So now come to the work done by tension force. So whenever I am applying a tension force, then also the body has been displaced. Okay. So tension basically, if I calculate, let us say there are two blocks. Let us say there are two blocks connected by a string. Let us say initially the let us say that there are two blocks A and B. You connect these two blocks with a string, and you pull this block B with a force. Okay. So since these two blocks are connected with a single string, can I say the displacement of the A block? Let us say displacement of A block is S. Displacement of B block should also be S.
Yes.
So now if I identify the tension on the A block, so tension on the A block should be in this direction. Tension on B block should be the other direction. Okay. So this small B point on which the tension force is acting on B block is displaced toward the right hand direction.
Yes, sir.
This point A on which the tension is acting is also displaced toward the right hand direction by same S.
Yes.
So work done by tension on A. So for A, theta is how much? Theta is 0 degree because both tension and displacement are in the same direction. So answer should be 2 into S. On B, theta becomes 180 degree. Why? Because T is on the left side and S is on the right side. So that means the answer for this work is minus TS. So if I calculate the net work done, that is 0. One number is positive, another number is negative, but if I add these two, then it becomes 0. Okay. So work done by tension can be positive on a particular block, can be negative on another block, but as a whole it becomes understood. Okay. So work done by the internal tension. Tension is an internal force. So that will develop on the string. So let us say for this particular situation, if I say that 2m block is displaced by a distance of s, then m should move upward by displacement of s. Can I say? Nah. So m
Yes,
is
sir.
moving downward means downward by s displacement. So m is moving upward for s displacement. Okay. So on 2m, this is the tension acting. On M, this is the different tension. Okay. So this tension, what done by this tension is how much? It should be equals to T into S into cos of 180 degree. Understood? That is minus S. On this, what is the work done? Work done should be T into S into cos of 0 degree. Why? Because the angle is now 0 degree. So this TS as a whole, if I calculate the net what? It is going to be 0. Nah.
Yes, sir.
So why? Because it is an internal force. It is a kind of internal force. It is developed internal. Initially the tension was not there. Once I hang the block, then only the tension will come. So tension acting within the system. So rope is our part of the system. So inside that string, the tension will be there. So string is a part of system. So on the system, it always zero. Okay. Why? Because length remain constant. Because I am talking about the ideal string.
Okay.
For ideal string, the tension is always equals to 0. Work done by the tension is always equals to 0 because one may be positive number, another may be negative. Okay. Both cannot be of same sign. Both cannot be of same sign. So what you can write, the product of T into X. What is T? T is the tension on one string and displacement on that particular string. That should be equal to 0. Sum of this number. So summation of T vector dot X vector. That should be equal to always. Okay. Understood? So one tension is positive, another may be negative. So addition, once I do the addition, because it is scalar number, no, we have to do the addition. So once I do the addition, then what you see that the answer for this part is always 2. Okay. So let us solve this problem. So mass of the particle, let us say given as 2 kg, is projected as shown in 4 different ways. So either it is projected upward or downward or sideways or any angle. So the same. In both the situations, the particle speed is equals to u. Here also projected u, here also u, here also u, here also u. Okay. Find out the work done by gravity during the time the stone falls on the ground. Okay. So if in all of the three situations, the path may be different. For the second situation, the path will be like this parabola. For the third situation, there will be another parabola. For the fourth one, it will be straight fall, vertical fall. For the first one, it will go upward, then fall. So path of the particle according to position 1 or position 2, it will change. But whatever is the path followed, the weight of the particle, that is mg, is always acting downward. Now, mg is always acting downward. And what is the displacement of the particle? It is 100 meter. Nah, displacement of the particle is 100 meter. Understood?
Okay, sir.
Why? Because initial point is this one, final point is that one. So Whatever the value with you they have been projected. Whatever the value of E that is immaterial because I want to calculate the work done by gravity. Hmm. So during the time, all the particle once it reaches ground, the displacement is how much? 100 meter.
Zero.
100 meter. Why zero?
Here is 100.
100 meter now. Whether the part is following the path number 1, 2 or 3 or 4, the final displacement of the part is 100 meter. Okay. So for
Yes,
this situation, what you can say, the mg is acting downward. mg is acting downward. And displacement is also acting downward.
Yes, sir.
Displacement is also acting downward. So AC is at the same distance. So ultimately work done should be how much? Work done should be equal to mg into AC. Okay. That means equals to 2 kg. 2 kg means 2 into 10. And AC is how much? 100. It's 2000. That's your answer. So whenever the particle is projected, following 4 different paths or 5 different paths, whatever be the path follow, I don't have to bother about it. I want to calculate the work done by the gravity. So work done by the gravity is how much? 2000. Okay. Understood? So that will be your answer. Now since what you can say, so this work done by gravity is nothing but our potential energy. Later on we understand that this number is not positive number, this should be negative. Why? Because in this situation the potential energy is being dropped. Potential energy is being dropped. So it has been reduced. So that means the negative answer should be. Okay. That's why the answer is negative. Let us say I want to calculate the work done by this force F, capital A, on A due to 100 meter displacement. So once we apply a force F of 120 Newton, so particle A is displaced by how much? 100 meter. So what is the work done by A? Work done by A is simply 120 into 100. And that number is positive because along the distance of force, the particle is displaced. So ultimately answer is 1,220 joule. Okay, that is the work done by the force.
Yes,
Now, in the same situation, you are asked to calculate the work done by the normal reaction on B and A. Okay, on B and A during the. So here you are asked to calculate the work done by the normal reaction between B and A. So assume this as a system. What is the total mass? 20 plus 10 is 30 kg. So you are applying a force of 120 Newton on a mass of 30 kg. So acceleration of the system should be equal to force by mass. 4 meter per second square. So entire system will move rightward with an acceleration of 4 meter per second square. Now you take simply B. If you do the force side on the B, so on B the acceleration is 4 meter per second square. So who is giving the acceleration? That is the normal. So this number n. N should be how much? N should be equal to mass of B is 10 kg into 4. That is 40 Newton. So 40 Newton is the normal force acting in between A and B. So on A, if I see on A, normal is in this direction. But for on B, normal is on the right hand direction. But in the process of doing so, both has been displaced by 100 meter. So work done by this normal, work done by normal on B will give 40 into 100 positive number because normal is along the direction of displacement. But similarly, work done by normal on A, that number should be minus 40 into 100. Why minus? Because now the angle is 180 degree. So it should be 4000. It should be minus 4000 then. Okay. So these are the two answers. One is 4000. By the work done by normal on B and A. First answer is B. So first answer is 4000 and then minus 4000. Okay, that will be your answer. So overall effect, overall is 0. One work is positive and another work is negative, but the magnetic part is both are same. So W net or net work by the normal force is always going to be 0. Okay. So like this, there are